Alright, so solving our quadratic equation. So we've done some of this already. We always make a quadratic equation equal to 0, okay, because when we're solving it, we're trying to find the x-intercepts, and the x-intercepts are where y is equal to 0. Okay, so first thing you do is you make it equal to 0. If it's already equal to 0, then you factorise it. Now we've seen there's heaps and heaps of different ways that you can factorise a quadratic equation. One of them is putting it into x-intercept form. The other one is completing the square to put it into turning point form. The other way is to factorise via grouping, and then you've also got it that you can take out the highest common factor when you don't have a y-intercept. Okay, if your y-intercept is 0, you can just factorise it by taking out a highest common factor. Then what you would do is you solve it based on the fact that it's equal to 0. Or generally, we're solving it using the null factor law, which means that whatever's in each bracket has to equal 0. So you solve for what the x is to make that true. Okay, again, you've done lots of it before. We're just going through the different examples to be a bit more explicit. So I've got a few different examples of the different ways that we're going to do it. Some of you already know and will remember. Some of you it'll be hopefully a memory jog. Some of you it might be the first time that you're seeing it. Okay, all of them are okay. That's why we're putting them all into our notes for reference later when we come back and have another go at it. All right, so first one that we've got there, we've got x squared take 6x is equal to 0. Okay, so the function's already equal to 0. The function that we would have had before would have been y equals x squared take 6x. Okay, that's all it would have been. But because we're solving for what x is, we make y equal to 0. Okay, because whenever we're trying to figure out our x-intercepts, y is equal to 0. Okay, so that's why we always make them equal 0. So from here, I can't factorise it the normal way where I'm looking for it being in general form, because it's not in general form. Okay, there's no y-intercept that I can see from this particular equation. Okay, because the y-intercept is at 0. So instead, we factorise by taking out the highest common factor. So for this one, the highest common factor is just x. So I take that out and I divide everything else by x. X squared divided by x leaves me with 1x. 6x divided by x leaves me with 6. And it's a take away 6x, so it's take away 6. So that's what it is factorised. After that, this is where the solve part comes in. So each section of that factorised expression has to equal 0. So it means that my first part, so my x has to equal 0. And it also means that x take 6 has to equal 0. Obviously, I'd continue solving that, so I know that x is also equal to 6. Okay, so that's the two solutions. They're the two x-intercepts of that particular parabola. Okay, it crosses the x-axis at 0 and at 6. Questions about that one? That's the easiest one, so long as you remember that that's what you do. Quite often when you're not given all of the general form information, people panic a bit and forget what they're meant to do. It's just general factorising. Okay? All right, with your next one, we can factorise it into x-intercept form. Okay? You have a look, you see, can you figure out two numbers that multiply to give you the constant and the same two numbers that add to give you the coefficient of x? Okay, once you've figured those numbers out, so what two numbers can we multiply to get -3 and add to get -2? -3 and +1. +1 times -3 equals -3. -3 plus 1 gives me -2. Okay? X-intercept form is when you've got your two brackets. So then I've got to have x plus 1 and x subtract 3. Okay? And remember, each bracket has to equal 0. So therefore, each x value is the opposite of the number that's in there. Okay? X plus 1 has to equal 0, so x must be -1. X subtract 3 also has to equal 0, so x must be equal to 3. So the next one, it's the same thing, but it's just not quite in the format that we want it. We have to have it equal to 0 for us to be able to solve it. So you're all clever enough to be able to rearrange it so that it is equal to 0. Okay, so in this case, we want to keep our x squared positive, so we're going to move the 30 across. So we're going to end up with x squared take 13x take 30 is equal to 0. Okay, I've made it equal to 0. Now I have a look at what form I'm going to factorise it in. This is another one. It's nice. I can think of two numbers that multiply to give me negative 30 and add to give me negative 13. Okay, those numbers are going to be 2 and 15. 2 15s are 30. I need it to be negative 13. So my larger number is my negative number. Negative 10 times negative 3 would be positive 30, and negative 10 plus negative 3 would be the negative 13, but it has to make both still correct, so that's why it's not 10 and 3. Does that make sense? So you've got to think about how your negatives work there. If you've got a negative, okay, as your constant on the end, you're going to have one positive bracket and one negative bracket. If you've got a positive on the end and a negative in the middle, then you're going to have, what did I say just then? Positive on the end, negative in the middle. It's going to have two negatives, okay? Positive in the middle and a positive on the end is going to be two positives, okay? So you've got to think about how they relate to one another. So again, we've got to finish solving it. So all of this is equal to 0. X plus 2 must be 0. X take 15 must be 0. So X intercepts in this case are going to be at 15 and negative 2. Okay, because that's what we're showing each time, what the X intercepts are. Okay, next example. Like I said, there is lots of examples just to show you all the different variations that you can possibly get to jog your algebra memory. So x squared equals 15x. Well, again, I've got to rearrange this one so that it equals 0. I want to keep my x squared positive, so I'm going to move the 15x instead. Okay, once I've done that, I factorise. This one again doesn't have a constant on the end, which means it must go through at 0. So I'm going to factor out the x. X is my highest common factor, so I'm going to end up with x take 15. So that means at one point x must equal 0 and x take 15 must equal 0. So I've got one solution. My other one is going to be x must be equal to 15. Okay, once you start plotting through, the only thing that changes really is how you factorise it. Okay, once you get to the end point of it being factorised, it's all the same. It's the opposite of what's in the brackets, or you solve the expression that you're left with. Next one's nice, it's already been factorised for us. Okay, so someone already did that factorising step, so now we can just use our null factor law to solve it. So what it's saying is 2x take 5 has to equal 0, and x plus 7 has to equal 0. So this is where again we're doing that little solve step at the end. So x must be equal to negative 7, 2x is going to equal positive 5, x must be positive 5 divided by 2, which you can all work out to be 2.5. Okay, so in this case x is equal to 2.5 and x is equal to negative 7. Pretty cruisy so far? Now, if you've just got x squared, okay, and you've got x squared equals something, or however you've got it worked out, what you want to do, okay, you can still make it so that it's equal to 0. Okay, so you could still make it that it's equal to 0. So you could make it x squared take 16 equals 0. And then you could factorise this one. Okay, can you remember how this one factorises if you don't have an x element, if you've just got x squared and a constant on the end? Good, so it's the difference of perfect squares, okay, because this number is a perfect square, I can square root it. So what it means is I'm going to have x plus 4 and I'm going to have x take 4. So my solutions are going to be x is negative 4 and x is positive 4. Now, there's a second way that you can do that one. You can do that one just in your solve context as well. If you've got x squared equals 16, well, the purpose, that's right, the purpose is I'm just trying to get x on its own. Well, x is on its own, it's just been squared, so I just square root it. So it's going to be the positive or the negative square root of 16, and that's what you've got to remember. When you square root a number, you can have the positive or the negative version of it. Okay, so means that x is positive or negative 4. Okay, both ways are correct in doing it. Whatever makes most sense for you to remember how to do it. Okay, so our next one is we've got to factorise through grouping. Because I've got this 2 out the front, okay, 2 is not a factor of 7, nor is it a factor of 15 without me getting decimals and awful numbers that aren't going to be nice to work with. So I've got to split the 7 up so that it shares factors with 2 and it shares factors with 15. Okay, so the trick way of doing that is that you multiply A and C. Okay, so that we get negative 30. Now the numbers that we're going to use here, okay, have to be factors of negative 30. Okay, so they have to be factors of negative 30 that can add together to give you 7. Okay, so think about that for a little minute. Factors of negative 30 that add together to give you 7. What do you think? 10 and 3, good.
But that doesn't divide by 2. 3 doesn't.
So it's not about, the 3 doesn't have to divide by 2, so we'll just figure out which way around it goes first. So I've got to have a positive 7, so it means I've got positive 10 and negative 3. 10 times negative 3 is negative 30. 10 add negative 3 is 7. So now I've got to put them in order so that they match up, okay, with the coefficients. So 3 goes with 15, 10 can go with 2. Megan?
Could you go with 4 and 3?
4 is not a factor of negative 30.
Does it have to be?
Yep. Otherwise you'll find at the end you won't get the same thing in the 2 brackets and then you have to go back and start again.
2 and 5 would have to match up with factors.
2 and 5 are both factors of negative 30. So it has to be factors of negative 30. So can you multiply them to get, yeah. So it's the factor pairs have to go together to multiply to that number. Yeah. So now I put them with their matching sides. So the 10 goes with 2. The 3 goes with the 15. Okay, once I've done that step, then I can factorise each group. So the first group, my highest common factor is 2x. So 2x squared divided by 2x leaves me with x. 10x divided by 2x leaves me with 5. Okay, and then again for the second one, negative 3x and negative 15 share a common factor of negative 3. Negative 3x divided by 3 is going to leave me with x. Negative 15 divided by negative 3 leaves me with positive 5. Okay, it's important that these brackets match. If they don't match, then it's not factorised properly. Okay, and you might have chosen the wrong numbers here, or you might have missed the negative element there. Okay, so x plus 5 becomes one of my factorised brackets, and the remainder, so 2x and negative 3, becomes my other bracket. So from there, then I go through my same process of deciding what x is equal to. So x add 5 has to equal 0, so x is going to be negative 5. 2x take 3 also equals 0. So 2x equals 3, x equals 3 on 2, which is simply 1.5. So when we complete the square, we end up with it still being equal to 0. We still do the same thing. So if we complete the square for this particular one, 0 has to equal x add 3 squared, and then I need to also take off 9. That works out, doesn't it? Half of 6 is 3, 3 squared is 9, so I have to take that off at the end.
Is that already equal 0, like the bracket?
Yeah, so this should have said, I should have written it out as either equals 0 or y equals that, so that it's an actual function, not just a expression. Alright, so from here, your solving's a little bit different, okay? So from here, we're going to solve based on the fact that it's equal to 0. So you have to do some rearranging, Toby. So what we do is we take the negative 12 and we put it on the other side. Okay, the next thing that we're going to remove is the squared. Okay, so we've just got to square root the 12. Now, don't forget you can have positive or negative root 12. Okay, and then your final step is to subtract 3. So this is one of those cases where we end up with an irrational number or surd as our answer, which is okay. All right, if it asks you to leave it in the surd form, then you would simplify this and leave it like that. Sometimes they'll ask you to do it to 2 decimal places, which means then you would chuck it into your calculator and evaluate that to 2 decimal places. Now, to jog your memory, if we simplify root 12, what 2 things can you multiply to get 12? One of them being a perfect square. 4 times 3, good. Square root of 4 is 2, can't square root 3, so the simplified surd of root 12 is going to be 2 root 3. Hopefully that jogs a few of your memories. So our answer is going to be 3 plus or take 2 root 3. Okay, and that's leaving it in its exact form. Again, if it wanted it to 2 decimal places, then you would obviously do that on your calculator. Will?
How do you know what to put in the brackets on the first step?
Half of this number. So it's always half of this number. And then on the end I subtract half of this number squared. I'll do some more completing the square with you separately. I skipped all the working out for it. Pardon? Yep. Yep. But I'll do some more practice ones with you because some people haven't done as much as others with completing the square. All right, very good. I reckon that'll be enough examples for today. So in your booklet, I want you to have a look at 6A. Should be the last page there where you're solving, okay, those quadratic equations. Do want to see working out in your book, so don't want to see you just doing it in your head, factorising it and stuff in your head. Want to see that you're practising how to factorise and solve them properly, please.